Alright, time for another draftphysics.com, debatephysics.com also. But, again, the debate is just terrible. People just can't respond in kind to these videos. So I go to the trouble to explain some physics. Frankly, when I'm not responding directly to some obnoxious jerk, then I just make the videos and make the points I need to make. Okay, so in this case, okay, when there's a Newton's cradle, you shouldn't be really impressed by the motion of the energy. You should really be impressed by the fact that you are creating positive momentum and then negative momentum and then positive momentum and then negative momentum that somehow are unmomentum, that somehow it's creating canceling energy. The system, somehow magically creates some sort of momentum that can cancel momentum in this direction, can get canceled by momentum in that direction. So every time a bomb goes off, for example, and pieces fly in both directions, there's no real energy in the universe. Nothing really happened because all of that momentum canceled. Yeah, the stuff going this way cancels the stuff going that way. So there's no work done, no energy used, nothing really happens. That's their argument. All right, so this is all connected sort of to the lever. Obviously, the lever is another device that converts direction. It just doesn't really care what direction something's moving. It doesn't have any notion that this is a positive direction and this is a negative direction or vice versa. It just has to do with a mass moving a velocity. And basically, you're just saying it doesn't matter whether it's going this way or this way. It takes the same energy to make it go either way. And I can make exchanges that way. So I guess let's talk about springs and guns first, I guess, just because it's on my mind as an example of where their physics goes all kinds of wrong. Okay. And, again, this is about the law of the lever, something really elemental. And they're claiming, even though people have believed it for 2,000 years, all of that time they've had this wrong notion about how levers work and that they don't actually conserve momentum. And somehow it's not a big surprise to anybody that that's what they're saying. That's what physics is saying. And nobody's shocked and amazed because they just don't care. As long as it preserves the Holy Ghost, it's okay. It doesn't matter what kind of bizarre story somebody makes up to explain why there's a Holy Ghost, say, in the Bible. They'll accept any story. Go ahead. Just make up any kind of story as long as you preserve the Holy Ghost and it makes sense because, obviously God wouldn't have talked about the Holy Ghost if he wasn't important somehow. It's just bullshit. And they're going to defend their sacred bullshit, and that's all it is. All right. So, I was just thinking, obviously these are experiments. They must be somewhere on the internet, but I'm not going through 5 million ballistic, gun videos to find it. But you could argue that if, you had a rifle and you were going to shoot bullets, yeah, it's a really crude rifle. And, the higher the velocity of the projectile, the more charge you can put in a lot of charge, you can put a little charge inside of a bullet. So let's just say you're doing a very high velocity gun. You're going to shoot a very high velocity projectile, and you're going to have a significant recoil from the gun. Now, the simple argument is have they ever tested it where, okay, they have a person holding the gun, and you obviously see the gun recoil, so they're absorbing some of the energy. And, doing the same experiment with, say, an anvil. Okay, a big heavy mass, and just have the gun supported, and then fire the bullet and see if there's any difference in the bullet's velocity based on those two experiments. So when the gun is capable of recoiling, does some of the energy actually that's going this way end up reflecting and push the bullet that way? So I would say the obvious answer should be that you can probably get 10% more velocity out of a bullet if you prevent the gun from recoiling, because then you're going to guarantee a more significant amount of reflection inside the gun. So the energy, the explosion's producing energy into the gun. Say this is the gun side. It's producing energy that's hitting the gun. And the fact is, if the gun yields, then the energy is absorbed. But if the gun doesn't yield and it doesn't move, then it has to be reflected, would be the argument. Now, so that you could do a simple experiment. You know, you have a so their theory basically says is that I can put a mass here, and then I could put a gigantic mass, okay, with a spring. And their argument basically is that I go to launch something, say I have the same mass, a one mass, and I launch it with the same spring compression in those two circumstances, that I'm going to get the same velocity here. So no matter what I put on this other side, I get the same velocity on this side. Now, I'm arguing obviously that doesn't happen. That's ludicrous. And the fact is that if I have something unmovable, okay, something that won't absorb the energy, that is, you can't dent it, you can't deform it, it's a big, solid, hard piece of, tempered steel. So the spring can't dent it. Nothing can cause any energy to be used by this object. It will not absorb any energy. That you're going to get twice the velocity from the same spring compression. Well, twice the velocity of the circumstance where, that obviously you have a very movable mass this way. So the same mass. So if I have this mass is a 1 and this mass is a 1, I'm going to lose half the energy moving this mass, is the simple argument. And in this case, I'm not going to lose any motion this way, and all of the spring's energy will have to go this way. And this will go twice the velocity of this. This is only going to get one velocity because it lost one velocity over here. And so this speed will be half of that speed. And I'm arguing that's real physics. So that's another experiment we need to see, that it doesn't make any difference how light or heavy the mass is on the other side of the spring, when all of you know it makes a huge difference. If I have a flea on this side of the spring, you know that this isn't going to get any energy, and the spring's going to try to go that way, and it's going to be pushing less this way. So we know that changing the mass changes how much momentum. You're not going to be able to say both sides will get the same momentum, because first off, the spring can't push a flea, so it's just going to be a spring moving that way, and it's not going to come back in time to push that any faster. It's already gone. So the spring's going to be left with a huge amount of energy in it, and the object's not going to get it. So again, I made a whole video on springs, so let me just do that real quick, because people are still using them as if you can use them coherently. So the real way to use a spring, to defeat the fact that springs have a failure, is to actually use a lever and have this spring attached to the lever, because then you can guarantee that you can put a mass at any one of these locations, 1 distance, 2 distances, 3 distances, and you can guarantee the velocity increase from the same compression of the spring. So I can just, this would be the law of the lever, I could put a 3 mass here and a 2 mass here and a 1 mass here, and I'm going to be doing the same. Well, that's not quite right. Yeah, but this would be a 1.5 here. So let's not mess with the 3, the odd number. You put a 2 mass here, you could put a 1 mass here, and you could put a 1/4 mass here. All right, that works better. Now that's only 3 distances, so it's still not right. So let's just do the 1 to 2, make it simple, and you'll conserve the momentum. I mean, you'll have every expectation. The half the amount of mass means the system has to do half the amount of work to move it, but it's going to do that half amount of work over this twice the distance. So it's twice the amount of time, amount of distance it's going to have to be accelerated versus the small amount of contact time here. I mean, it's the same amount of time, it's a different amount of force being applied. So it's half the force at twice the distance. Same difference. So it's twice the velocity. That's the expectation. I'm just saying that's the law of the lever. This goes twice as fast. Half the mass, twice the distance, twice the speed. And they're saying that they have some evidence that that's not true, that modern science somewhere did the experiment and proved it. Well, obviously there's no experiment that proves it. So anyway, the spring argument is that the spring would move exactly the same in both cases, and therefore there'd be the same loss of energy to any motion left in the spring. The spring isn't free to expand after the experiment, and that means it can't lose any energy. Where if I don't use a lever, obviously if I compress a spring and I let it expand all on its own, it's going to wobble back and forth significantly. But the heavier the mass I put on the spring, the more I reduce how fast it was going when the object leaves. So when the object leaves, it's going 10 miles an hour, let's say, then the spring still has 10 miles, it has 9 miles an hour still left in it. So it still wants to go out and expand. But the faster I let it, it could be 100 miles an hour here. So the spring has all the energy in it, and it's going to oscillate a lot. Here it's going to only have 9 miles an hour of energy left in it, so it's going to oscillate very little. So the heavier the mass, the more energy that goes into the object. And the lighter the mass, the less energy goes into the object. I mean, it's an important piece of physics, understanding how things mechanically work. And it's just an absolute truth. If you use a raw spring to push something, it will push heavy things much more efficiently than it will push light things. The lighter the thing it's pushing, the more energy you leave in the spring. So you have to use a device to compensate for that, like a lever. All right, so yeah, I guess that's enough of the beginning. All right, so the Paul Nord has, for no good reason, I would say. I mean, the state of things are. I don't mind. I mean, if he wants to somehow reclamate the conversation, that's okay with me. If he can make an argument of some kind or link to some evidence, I'm perfectly willing to look at it. I'll watch videos. He won't, but I will. All right, so the comment we left off with is, Steve makes a mistake at the 5-minute mark. So that's what that's what Paul accuses Steve of. Okay, and I said, you didn't watch the whole video, did you? So it's his question. He's not going to provide an answer. A bit after the 10-minute mark, he states exactly the opposite. Okay, in the first half of the video, he was explaining his intuition. Later, he states he thinks the actual science is, and of course there's no citation to any evidence. So the point is that he completely, throughout this whole 2-week period, he's completely misunderstood Steve Mould's video. So he's sort of the dumbass here, kind of obvious. All right, dumbass. Yeah, okay. You claim to know something about the history of mv squared, and you don't know that Leibniz's only claimed evidence was the statement that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. And again, we don't have any experimental evidence attempting to collect the impulse energy of 1 pound going 2 velocity and 4 pounds going 1 velocity, and we're supposed to believe, even though they have completely different momentums, that is, one of them has twice as much momentum, we're supposed to believe they do the same work. You should be equally afraid of them. If I give you a choice to have one of them smash into your baby, you should choose either one. It doesn't matter, flip a coin, because one of them doesn't have half the energy, obviously. Okay, I offered more than a dozen of your colleagues $4,000 to deal with this subject, and none of them showed any courage. Your evasions and petty insults are now a matter of record, and you will be eventually proven to be the science denier. So look, the real accusation is this isn't physics, it isn't science. Science is showing things, producing evidence, doing the experiments. And again, all of these experiments are really easy. You don't need trillions of dollars. You don't need nuclear cell accelerators. All of that crap. The Eddington experiment, for example, you can do it from space with a GoPro camera, and they haven't done the damn experiment. All right, so his response is, you continue to amuse me. So, typical troll bullshit. Please build a working model of your physics you propose. So I do have the simulation of charge that works perfectly, but again, it's a video that, it might be 6-7 minutes long. It's way over your pay grade, right? You can't handle that. You're too distractible. You got too much ADHD stuff or something. You can't pay attention for 7 minutes, can you? Um, so I don't have to build the model. I've described the model in detail. Yeah, my claim is yeah, the real universe is electrons and protons. Everything has to happen there first. Do you have some evidence that that's not the way it works? That action happens somewhere else first, and then the electrons and protons have to obey? After the event already took place, they figure out where to go. No, it's not. But anyway, and then he says, spend your money on a college course. Yeah, taught by a propagandist, a person doing their catechism. Jesus, love, happy, Mary, love, love. It's baby talk. It's beneath contemptible bullshit. It's Sasquatchian physics. Doesn't have anything to do with reality. All right, so I said back to him, well, I can just thank you again for proving my point. You are just despicable cowards proselytizing a religion. You never answered my question. How much would you be willing to wager that levers actually obey the law of the lever? And, of course, get what you deserve. So, so he didn't take any account for the fact that he misrepresented Steve's video for 2 weeks. He didn't say, yeah, you're right. I didn't pay enough attention to this subject. I didn't really watch the video. I'm a little bit arrogant and full of myself, and I just don't think I should have to be bothered with details. And I don't have to get any of them right. I have a formula. I love my formula. I just paste it everywhere I have to, and I just say F equals ma, and I presume that everything is just fine. Even if it gets a wrong answer, who cares? NASA is smart enough not to pay any attention to kinetic energy, so what's the threat? There's no threat. I mean, NASA's not going to tomorrow say, oh, yeah, kinetic energy is real and we better account for it. Yeah, no, because it doesn't work. And they know it. And that's, again, part of the whole Dumb and Dumber kind of atmosphere is they know that it doesn't work. And instead of saying, well, we don't use it because it doesn't work, they just pretend that, oh, yeah, we like to do the Newton thing when we're in space. But, Newton was a fun guy. And, Newton is good for space. Some kind of crap like that. Some sort of crap that doesn't explain why they don't use their new, improved, better theory. Yeah, because it's not new and improved is a simple answer. Truth. And such. Alright, so I think I'll just attach this video to one of the other videos on the related subject of kinetic energy versus momentum, and the more specific argument was about levers and such, but this is close enough. Okay, so in this case, first the comment regarding his spinning lever. I probably shouldn't have referenced any of his experiments because, yes, okay, if one thing isn't broken, it's going to be something else. So he explained the clip thing. So in the video, you had no idea. I'm just saying I did a perfectly reasonable thing. I noticed that one looks completely different, and I assumed the washers were the same mass. So I didn't do anything wrong. I did something perfectly sensible, which is I saw something that had every appearance of being an irregularity. All right, so the fact that his video doesn't explain how he's doing the experiment at all is just a fact, okay? He's just showing results. He's not showing how he did it, and that's the bullshit part. All right, and so I responded. He says, so a commenter says, so apparently the clips were taken into account in Dispar's in Dispar's drill experiment. And it's a drill experiment, which isn't even... As a source of impulse, this isn't exactly Einsteinian, and so why doesn't he measure how much electricity the drill uses when you spin it 5 times as much? Yeah, why don't you do that experiment? Okay, he's still a long way from making the video credible science, is my argument. In the video, we have no evidence that he actually has the masses at the right location. So if you do look at where the two are superimposed, yeah, it looks a little off, especially on the right side. That the lighter masses are a little too far out. Okay, if you look at the still image where the two experiments are overlapped, there's every appearance that the lighter masses are too far extended on the lever. Then there's the issue of how he has ensured the same impulse input energy. So there's nothing, it's not like he's using a spring or a rubber band, some consistent source of relatively consistent. No, he's using some sort of gear work inside of an electric drill, okay, which really isn't a great idea. With the weights spinning vertically, the absolute weight of the experiment is higher than the other. So obviously, in one experiment, there's twice the weight on the lever. It's just a fact. There's the whole lever, and the whole experiment weighs twice as much, almost twice as much, in one case than the other case. And so things like static friction and other things are reasonable things to say, okay, if you're going to put in a little bit of energy, one of them is going to have the advantage because there's going to be more static friction if the bearings suck. Now, the bearings in drills really aren't, they're not the greatest bearings in the world in terms of something light spinning. They're made to take a tremendous amount of torque and, twisting forces. Anyway, with the weight spinning vertically, the absolute weight of one experiment is higher than the other, meaning a bit more weight on the bearings, which means a slight increase in static friction. You're also moving the armature of the drill, okay, meaning a bit more, okay. Do you have any idea how good the bearings in the drill are? I asked the question. Are you certain the outcome of the experiment would be the same if he did it horizontally? So the trick to get rid of the weight issue, at least on the bearings in one direction, is to do it horizontally. Now, the experiment still weighs more, but the way the weight is going to be distributed is completely different. He's claiming to disprove conservation of momentum and the law of the lever. Do you think this experiment is credible quality to do that? Yeah, good question. And you think it's my obligation to prove his errors when he doesn't provide any information regarding how precisely he has accounted for the various variables. Just a fact. All right, so now he's actually made a video where he's going to argue the physics. Now, it's only 3 minutes, okay, so it's going to be a shitty argument, no doubt. But why not? We'll play that. So physics arguments, crappy experiments. No, I don't want to spend my life debunking shitty experiments. Let me hear you explain the physics. How you understand the physics to create this free momentum. Because again, I just argue there's no way to do it mechanically. If you understand that physics is atoms, and that atoms are doing the real moving, the electrons and protons, and they only have so much energy, so much movement to distribute, and they can't make more atoms move. Okay, one atom can only move one other atom. It can't move two atoms at the same speed it's going. It can't do that. All right, and so you don't have any theoretical ground. So we'll play this. I only played 36 minutes, and so I said, oh, what the hell, let's just play the video. It's only 3 minutes. He won't be surprising me with anything because he's an idiot, okay, and an asshole. And a fucktard. Speaking of fucktard, yeah, that's right. I have to increase the sound on the video. Okay. All right. Somewhere around there we should do. All right. So let's play this piece of crap. And such. Hit the play button.
All right. This is going to be another counter argument regarding the free momentum stupidity.
Okay, he says another. There's no others. They haven't counter-argued anything, so what's he talking about? What's the other?
So now you can continue to lie that no...
So where's my lie? Where's the previous explanation about how free momentum makes sense? Where somebody drew the experiment and explained how, yes, you can make the three mass move with extra momentum in the same direction. And that's not at all going to create free energy machines. So he's not going to touch my free energy machine argument. That's the one he has to mechanically debunk, how I can't make that machine using his physics. So that one he's not going to touch.
What is capable of making videos and producing a rational counter argument.
Right, so I'm lying about it even though he can't link me to the previous argument. So I state that no one's made a previous argument, that no one's made a counter argument, and he's saying I was lying, when no, at the time there was no argument. And now there's a 3 minute, 19 minute, second counter argument. Isn't that exciting? 3 minutes and 19 seconds. I'm sure you're going to explain an awful lot of physics in 3 minutes and 19 seconds. Yeah, that's satire. You might not get that.
And so, well, regardless, let's do this. So I'm talking about the 1-3 mass ratio collision.
Right, so this is the one where they create 100. 100 energy, momentum goes in, 150 goes that way, right? And 50 goes that way. So I made 200. So I had 100 atoms moving in the universe, and now I have 200 atoms moving, this, if we reduce it to the same speed for the atoms. Right, so I have 100 atoms moving a speed. Now I have 200 atoms calculated to move that speed.
Between pendulums, your model predicts that after collision they will reflect with 1/4 of the initial velocity. Conventional science predicts they will reflect with 1/2 of the initial velocity.
And frankly, they don't predict anything. They don't even talk about that because they don't really want to talk about the fact that they've created free momentum. They just say something like 3/4 or 2/3 of the original velocity, but they don't really deal with the fact that it's extra momentum. So none of them say, yes, we just made free momentum in a direction. None of them say that.
But what happens is, at the moment of collision,
Yeah, so at the moment of collision, all you have is that 100 momentums worth of pressure. So you have a weight. So a weight now exists between those two objects. Say it's 10 pounds of weight. And now you're going to distribute that by making 20 pounds. And that's nonsense.
one mass will reverse its direction. All right. And in order for that to happen, in order for the direction to be reversed, first the one mass has to transfer all of its momentum to the three mass.
Now, why is that an obligation? That's the thing that's impossible to understand. If it transfers all its momentum, then it would be the three mass would take all of the momentum. It's not going to give anything back. The whole point is it's rejecting some portion of it. It can't take it. It won't take it. Its electrons go like this, and its electrons say, you didn't give me enough energy for me to keep going that way, so I'm just going back home. And that's what happens. They go back home and push the thing off their surface. So all you're getting is a reflection of the electron pressure. The electron pressure doesn't move to the other end. It doesn't get there. It doesn't move the object. That's why it doesn't take the energy, because it has to convert it into a different velocity. That's the simple answer.
Because what happens at the moment of collision, the one mass, there is a certain point where the one mass comes to a full stop.
So this is all irrelevant. This doesn't have anything to do with the argument. The argument you have to explain is how you're making free momentum, and that's not consequential. How the extra momentum in a direction doesn't mean anything in the universe. There's not really more momentum in the universe somehow. That's the part you have to explain.
All right, and at this point, its momentum has to be zero. It has to be. And then after...
Okay, so this is your talk, baby talk. Sorry, I don't know, it doesn't have to be. It's just absolute bullshit. The atoms inside are the ones doing all this motion. The motion is in the objects themselves, okay? It's their electrons and protons that are going to exchange their energy. So you're not looking at the exchange of the energy. You can't see inside. I mean, in your fucking opinion, you're a fucking idiot. You think we're just sitting here in gravity and we're not moving. That we don't actually get pushed into the earth, and the earth doesn't always constantly push us back out. You think it just happens once and that's it. Now we're just sitting here still. Nothing happening. The earth only had to push back once, and it's all over. There's no continuous force that it has to fight. Fuck you, idiot.
afterwards, three mass pushes the one mass back. Okay? Now,
No, that isn't okay. He pushes it back. Why? I thought you said it took the energy. Once it takes it, why is it going to give it back? It accepted it. It said, thanks. I got your energy. Thank you. I'm leaving now. Why didn't it do that?
so let's say the one mass is coming in at 10 meters per second in this direction, which means that the initial momentum is going to be 10. Then you say 1/4 of the velocity, which means this one will...
I don't know why you erased it, but whatever.
reflect back with 2.5 meters per second, so its momentum after collision is going to be 2.5, and this one will be 7.5. 7.5.
Yeah, the momentums, that's right. 3/4 of the velocity. I mean, the momentum will be in one object and 1/4 in the other, making perfectly good sense.
Okay, so and 7.5 plus 2.5, that equals 10. And so momentum is conserved, right?
Yeah.
Wrong. So what's the problem here? So the initial momentum was 10. P initial is 10. And then it gave away 7.5 to the 3 mass. So it is still left with 2.5. The 1 mass still contains 2.5 momentums, which was not yet transferred. But what do we know? At a certain point during the collision, the 1 mass has to come to a full stop.
So he does it again, so it doesn't make any difference. So he's basically saying, look, when a lever, 100 goes in this way and 100 comes out this way. That's what levers do, okay? They reverse the direction. A brick wall does the same thing. Lots of things do the same thing, but the lever's proving to you that direction is irrelevant. There's no such thing as a minus direction. All right, so I get 100 plus 100. I don't have minus 100 in the universe when it comes out the other direction. There's still 100 in the universe, and all you did was change the direction, which means nothing. So if it just hooked onto the lever, spun 1/4 of a movement, and then let go again, I've changed the direction. Is it somehow a 45-degree change? Is that somehow a negative? What is that exactly? If I change its direction by some angle that isn't exactly the opposite, is it half of a negative, 1/4 of a negative? How much of a negative direction is 90 degrees? If I change the direction by 90 degrees, how much of a negative is that? I start with this and I end up with that. How do you do that addition, fuckhead? Yeah, it's just such nonsense. You could figure this out on a pool table, for fuck's sake. You cannot create extra momentum in the cue balls and the regular balls. You can't hit one and have more momentum leave. It's not possible. So if I shot one ball into two, nicely spaced, I'm going to lose energy to both of those, momentum. And that's all there's going to be. I can only exchange my momentum, and nothing's going to be, oh yeah, because it's a 90-degree angle, that's sort of half, that's half squirrel, half, fig tree. And so therefore I'm going to, pretend it's some sort of negative amount of energy. It's not a negative amount of energy.
And when that happens, this momentum has to be 0. So at first it has.
So he says, whatever this even means. It has to be, he keeps saying, because it's not moving, that means we know that the atoms aren't moving, there's nothing vibrating inside, nothing's happening at all. Because the outside surface isn't moving, that means there's no energy inside the object. Which is obviously just a pile of shit.
To transfer all of the 10 to the 3 mass object.
If it was transferred, then the 3 mass would be moving with all of the momentum, and it obviously doesn't leave with all the momentum, so it didn't work. It didn't get transferred. If it has all the momentum, it would have left already. It hasn't left already, has it? Oh, what a piece of scum.
This cannot...
I mean, you could take a picture of a Newton's cradle and none of the balls are moving. And in the very next frame, they're going to be moving. Are you going to say there was no energy in the Newton's cradle when the balls weren't moving? It would be a ridiculously stupid and ignorant statement. Is that going to be your statement?
Not happen, because if this were true, if it only gave away 7.5 to the 3, and this one is still left with 2.5 going in this direction.
So again, he keeps thinking this direction could possibly mean something when we know we can change direction for free. I can put the energy into a spinning wheel and I can leave in any direction I want to. It goes in one direction, it comes out any direction you choose. So how the hell can direction have anything to do with it? Oh, that's right, it can't.
It cannot possibly reverse its direction if it still has 2.5 momentum.
Well, why not? What's the law of nature that says you can't reverse the direction? That things can't reflect off surfaces. They can't bounce.
If it did not...
So that's their theory. Just let's understand. I throw a tennis ball at a brick wall with 100 momentums. It bounces back, let's say, with 95. It's a really bouncy ball. So I get almost all of it back. And it pushes a spring and going to throw again. It pushes the spring, going to throw again. Right? their theory is that twice the energy went into the wall. It's that idiotic.
Transfer all of its momentum to the heavy mass, and it's still going in this direction. It cannot go and reverse its direction.
Right, you can't have a reflection. So he's basically just saying there's nothing could ever reflect in the universe. That is, a light thing can't hit a heavy thing and bounce off. A bullet can't reflect off of a windshield, for example. The whole car has to be moved twice as much energy has to go into the car that you bounce the bullet off the glass. Oh no, that's not true. Right? So that's not a complete reversal, right? The bullet doesn't bounce back, but clearly it's moving at a new angle, and it only gave away a tiny amount of its momentum. And that's the truth of it. Things reflect off surfaces all the time. It's a common function. You're an idiot.
That's the big contradiction which you failed to grasp.
Okay, so he's not really debunking the argument. So I'll draw the free energy machine again and then ask the question, why don't you just deal with the real subject, you lying sack of shit? Will be explained in the next video. So this is a waste of time. I'm not going to watch it in pieces. So if you can't make your videos in some coherent way, I'm not watching individual videos and enduring your silly commercials on them for this kind of nonsense crap shit. No, not going to happen. All right, so at least I will draw the experiment properly. All right, and so let's understand that they're taken to its extreme. So let's take it to the extreme. The extreme is that, okay, I put 100 momentums in. And if I put a big enough object here, I can still get it to absorb the momentum, still move. And their claim is, oh, I have to fix that focus, sorry. Pause for a moment. Well, it appears I made a mistake and erased the video. So I'll have to just redo this part. So the part you have to explain is the consequences of what you're arguing, which is you're basically saying, you can make all of this free momentum. You can get all your energy back. So the idealization would be that, you put 100 in momentum, some height, and their theory is if I make this mass heavy enough, just heavy enough, might be 10 pounds. So this might be 1 pound to 10, 1 to 10 ratio, something like that. And what I'll do is basically put 200 momentums, okay, into the object. And I'll get almost a perfect rebound of my 100 I started with. So like Steve Mould demonstrated, you can bounce a hard object on a surface 256 times. It'll just keep bouncing 256 times. And in theory, if you can get a good enough vacuum or get a good enough circumstance where there's no losses, it would just go on forever. Okay, and each time it hits, it's putting energy into the surface, real momentum, real serviceable motion. And so that's sort of their argument. So obviously I could build a machine that just fed weights very gracefully, one at a time, and it would hit, and then I'd get my 100 back or close to it, okay, and let it hit again, and let it hit again, and let it hit again, and I could get hundreds of times the momentum I put in objects, heavy objects moving. Now obviously I could hit those on a lever and just reconvert the energy back into light things moving fast without any issue, frankly. Okay, it'll work even if it was 1.4. Even if levers were momentum destroyers, I'm still going to get enough of the energy back to create a perpetual motion machine. Now, if I use their more realistic numbers, so let's just play with their actual, the lesser version of it. It's still just as perplexing to understand what the hell they're saying you can get away with. So it's this idea that if I hit something and it moves, I can't get a reflection, okay, 100% reflection, because the thing moves. So obviously I lost some of my energy to it because it has it. And the less this thing moves, the more likely I'm going to get a reflection. So if I throw a ball at a brick wall, I can expect to get a lot back because the brick wall isn't going to absorb any. And the more flexible I make the wall, the cardboard or something else that can move, the less I'm going to get back. I mean, it's just so obvious. And they're arguing that that obvious truth somehow isn't obvious. So in their case, okay, the numbers would be more like, okay, I put 100 in, I get 150 out. So I've already increased the amount of momentum I have. So, so many cases like buildings, knocking buildings down, wouldn't it be a huge advantage to be able to put 100 in and get 150 momentums out? Almost, a 30% increase in your momentum, total momentum. Anyway, and then I get 50 back. Okay, so now it's 50 in. Okay, so I got half my energy back, and I put 150 going forward. So I got more momentum going this way, and I get half my energy back. Right, so now I can have 50 hit. All right, and I'm going to get 75 going this way. So now I have an object going 150, and I have an object with 75 momentums. And then I'm still going to get back 25. Okay. And so we can do it again, and I'm going to get whatever, 37 or something like that. And I'll get, 13 here back again. So you can see I can get 300 momentums. I can put 100 in and get 300 units of momentum coming out. And again, what is momentum? But understanding the fact that everything's made out of cells and everything's made out of atoms. And they all have a mass, and it's the mass of those atoms that's going to decide how much momentum something has. So how can I take, realistically, how can I exchange with something and I give it more momentum than I actually have? All right, and I get some energy back to do it again. And then I get some energy back to do it again. That's what they're defending as a reality. And obviously, I'm saying this is what you have to explain. How this isn't free energy. All right. Because it is. It just is, right? I could just put a lever here. Okay, and I can convert this 150 right back again into, smaller objects moving with 150, momentums. So I'm gaining free capacity to do more work. Doesn't make any sense. And like I said, if I make these masses heavier and heavier, I'll get even more. And then the other side of this argument is what happens in the actual pendulum, where both sides have to recollide. Well, their argument is I could have a pendulum. Okay, I could collide two objects, and one with 150 momentum and one with 50. I could have them crash into each other like cars, and I could have the expectation that so a total of 200 momentums is going to crash, and somehow only 100 pops back out. So I had 200 momentums in the crash, and somehow, and it's perfectly elastic crash, no denting, no deformation, and somehow only 100 pops out. They think that happens somewhere on Earth. And obviously the argument is, no, it doesn't. You have to conserve momentum. And direction doesn't matter. All motion in the universe, any motion in any direction is momentum. There's no such thing as unmomentum or negative momentum. It's just not a thing. So that's the argument you have to deal with. Okay? Telling me how you think when two things hit each other, what you think happens, on the microscopic scale is irrelevant to the actual product. And the actual product of your experiment is the creation of free momentum. And that's what you have to deal with. Free motion in the universe. More things are moving. More atoms are moving with more quantity of motion. And that's an unviable notion of reality. It's not true, and you're never going to produce any credible evidence that it is true. So, yeah, that's a good enough version. The first version was probably better, but who cares? Close enough. All right, so I guess I'll throw in a couple of the comments after the Dispar 3-minute video. Anyway, so it says, well put forward here, Dispar. I doubt he will counter this argument, much like all the others we all present. So I don't know what others they're talking about. Maybe Ian Gosling's brilliant presentation where he explained how twice the velocity goes 4 times the distance in space. Yeah. Yeah, that was a really good argument. Or the one where he, 2 pounds weighs 4 pounds somehow. You put 1 pound on a scale, weighs 1 unit of energy. You put a second 1 pound on it, somehow it's 3 units of energy somehow. Anyway, he seems focused on Paul Nord at the moment, who isn't yielding to his demands of agree with me. So that's the silly part. The only part I'm wishing to get agreement on is that the evidence is insufficient. That in 350 years you think they would have done a couple of these simple tug-of-war experiments or dropping things experiments. And the fact that these assholes won't agree that it would be really good if science actually did these fundamental experiments, that's the part that's just so obvious, that their agenda isn't anything like science, because scientists should love experiments. More experiments, the better. Still working on my next experiment, but having a few teething troubles building the apparatus, which will be a monstrosity, no doubt. But I've ordered another part, which I'm hoping to resolve the issue. So I'm thinking, yeah, well, we'll see. I'm thinking of doing a comparison between equal momentums, 5 mass going 1v and 1 mass going 5v. And you realistically think that the 1 mass going 5 velocity is going to be 25 times more powerful. You really think there's a hope for that? Anyway, then equal a 25 mass at 1v against, I think that's what it says, let's see, and a 1 mass going 5v. So again, none of these things will demonstrate kinetic energy has any meaning. It's going to demonstrate that it's useless. It won't do any visible work. It won't win. Fact. All right, just hoping the springs work out. So this is the part where, okay, we're in trouble with springs again, because he's not going to use them. He's not going to put them in a circumstance that neutralizes their defect, because he's just too stupid. I ordered some more, but didn't realize they are from China, so waiting a while for them. But found a UK seller, so ordered one there too. So, the very fact that you're ordering springs is contrive. Anyway, so there's so many ways you can do these experiments. Even rotating something, where Dispar is rotating it with a drill. He could just put a rubber band on it and turn the rubber band exactly the same tension on both experiments. But whatever. Yeah, whatever. So Ian Gosling here. Dear Dispar. So dear. That's kind of weird. No space. Nice to see you're a left-hander like me. Good work. Whatever that is. So this is the only part I thought was a little bit interesting. Now that I look back at your theoretical videos, there's no theory. He's claiming that you can't slide across thin ice. So again, that's not a very bright argument to be making. That it doesn't work. Going faster across thin ice doesn't stop you from crashing through the ice. I see. I've never noticed it. Okay. Hope you're doing well. In case you're interested, I've ordered myself a 1 kilogram and 3 kilogram iron balls. I'm going to go big. But what you should have done is gone longer with the pendulums from the very beginning. I mean, I've argued that. When I did the experiment on my porch, it was 8 feet long pendulums. Much better. You asshole. And so it says iron, so maybe they're steel. They really have to be chromium, coated and all this other stuff if they're going to be at all elastic. The last thing you want to do is take a cast iron ball and crash it into a cast iron ball, because that's not going to be very elastic, idiot. especially at that weight. You're just going to dent the frickin' things. But we'll see. So apparently he doesn't even watch these other videos. Steve Mould's video where he got 256 bounces. You're better off with your idea of using glass. And obviously you used heavy pieces of glass, you'll probably break the glass. So that's not going to work. But whatever. Too stupid. So that's enough of that crap. They're just trying so hard to force the truth to bend to their perspective. And it's, there's just nothing scientific about forcing experiments to come out your way. But anyway, enough of that. And I'll pause and see, I don't know, maybe I'll just leave this video at that. I don't know if there's anything else I have to go into. See if I have any more comments. Alright, might as well take care of this stupid comment. So again, it's more of the same bullshit. So apparently the clips were taken into account in Dispar's drill experiment. Obviously it wasn't taken into account in the way he presented the experiment. Alright, and so there's no way for somebody looking at the experiment to know that he's using different size washers or any of that kind of crap. So it just has to do with the fact that the videos they present are not complete, right? And they don't provide you enough information to say it's a credible experiment. So I say he's still a long way from making a credible science. In the video you have no evidence that he actually has the masses in the right locations. They don't have to be much off to cause an effect, by the way. If you look at the still images, there are two of the two experiments are overlapped. There's every appearance that the lighter masses are too far extended on the lever. Then there's the issue that he ensured the same impulse input energy. It's a drill. Okay? It's not really made for really delicate motions. With the weight spinning vertically, the absolute weight of one experiment is higher than the other, meaning the bit more weight on the bearings, which means a slight increase in static friction. So these are all things to take into account and understand. Okay, is there any explanation for how he has really great bearings in the drill? No. Do you have any idea how good the bearings in the drill are? Are you certain the outcome of the experiment would be the same if he did it horizontally, this way instead of this way? He's claiming to disprove conservation of momentum and the law of the lever. Do you think this experiment's a credible quality to do that? And you think it's an obligation to prove errors when he doesn't provide any information regarding how precisely he has accounted for the various variables. So, I mean, they're just junk experiments again, and so you're just going to sit there and double down. So, I've said it before, I mean, as long as he keeps leaving videos up that are overtly flawed, the ones that are provably in some fundamental way absolute shit, and he leaves them up, until you have a defense for that, I'm not putting up with it, okay? So you can keep linking to his shit and I'll just block you. Because I don't have an obligation to do this. I don't have an obligation because some asshole makes some fucking cardboard crap experiment that I have to show up to debunk his crappy experiment. It's not my obligation because they're all crap. And that has been proven over time. That he doesn't take good care. That he is a slob about how he does the experiments. So you're just being a fuck. Alright, so it says he's still a long way from making a video. He's still a long way from making his video credible science. And this guy responds, sure, it's just a single experiment. It's not about being a single experiment. It's about it being a shitty experiment. One with a bunch of unknown variables. Okay. But the thing is that so this is the lie. We did Brozo's experiment. Go back to the billiard ball experiment Brozo did, and it's not even close to showing 1.4. So fuck you, it's not all. Show the same thing. Simpler example. So this is a piece of shit. Okay, it's a 30-second video, 20 seconds of crap. Okay. I don't know what this one is. I didn't bother. I don't have any obligation to look at these edited pieces of shit videos for which I can't do any scrutiny because nothing's shown. How it works, how you built it, nothing. Okay, and all these experiments. Yeah, fuck you. Let's see. If you look at the still image, let's see what he says here. It seems that they were filmed from slightly different points of view, unfortunately. Well, you don't think any of that shit matters, right? So parallax doesn't matter. It all does. That's what's been found out, that you can't rely on anything. But you think that's good science, not being able to depend on what you're seeing being accurate. That doesn't matter, right? It's science. Science doesn't need to be accurate. All right, then he quotes me again saying, then there's the issue, has he ensured the same impulse energy? Why wouldn't the drill put out the same amount of energy? I don't even understand how you can say that. He's hitting the trigger. Well, how do you get the same energy out of a drill? Sorry, I don't have that experience with drills that they have some button that says 1 joule of energy on it. It doesn't have like a button that says 1 joule, 1 joule. Okay, especially if he can feel the difference. So fuck this. All right, more weight on the bearings. Okay, let's see. But the heavier setup was the faster one. Yeah, that's not the issue. The issue is that you're changing how the experiment functions. So again, you could go to other friction arguments where you can point out that depending on, what's the right way to put it? How the energy is distributed through a system, whether there's any kind of slippage or other kind of things. So it doesn't mean anything. It's just pointing out that is there any way to account for it? That have these variables in any way been figured out as how does it change how the motor spins, for example, the armature, how it lines up or sets up? Or you have any guarantee that the motor doesn't work better with a little bit of torque on it? Because it forces the armature in one position. You don't know. You haven't seen a tool where if you bend it or twist it, that it applies more torque. It's uneven. All right. Well, anyway, are you certain the outcome of the experiment would be the same if he did it horizontally? Pretty sure, yes. Okay, so whatever. The argument is shouldn't it be done to see if there's a difference? That if it makes a difference. Okay. He's claiming to disprove conservation of momentum and the law of the lever. You think this experiment is a credible quality to do that. So here's the joke. He's not claiming that. So what the fuck? You're an idiot. Yeah, he is. So go ahead. Have Dispar explain to me how if the lighter masses are magically too heavy to move at twice the speed, how that isn't a violation of the law of the lever. Because the law of the lever says it's basically mv has to equal mv. That's the law of the lever. The momentum has to stay the same. Okay, you just don't understand what the conservation of momentum. So that's just bullshit. So I should block you right for that statement alone. It's idiotic. Okay, the law of the lever is basically saying distance. Distance is exactly correlates to velocity. So it's just force times distance, force times distance. So it's the same thing as saying mv, mass times velocity. Has to be conserved. Levers have to conserve it, and that's the law of the lever. So you're just a lying sack of shit. All right, momentum or the law of the lever actually mean? No, you don't understand. Okay, clearly. If your physics... It's your physics that breaks these laws. Lie. Just an absolute fucking lie. So, fuck you. Fuck off. I don't know why it does that. Alright. So, enough of that shit. Yeah, so we'll see. Because if he can make more of his little 3-minute theoretical videos, I'll play them. Because that's the only part I want him to do. Okay, so I want him to explain how free momentum isn't a problem. That you can make all the free momentum you want, and that's perfectly consistent with Newtonian physics, Descartesian physics, and Galilean physics. Free momentum is a real thing, and it's like they all knew about free momentum, and it's not a problem. It doesn't mean perpetual motion machine. When of course it does. All right, so that's enough, I think. Yeah, that's enough. So, till the next time and such and so forth and whatnot. Yeah. And yeah, get all what you deserve, which you're already getting. I mean, it's quite obvious we live in idiocracy, and science is basically just another idiocracy. You just have a bunch of naked emperors running everything, and you're too fucking stupid to do anything about it. Pathetic. Stupid, moronic, ignorant humans.